The columns or attribute in a table, they are most categorical and numerical variable. We show you the line chart and scatter charts. They're suitable for the numerical variable. So in this video, we'll show you if we have categorical data, which kind of chart will be best to demonstrate. So the example here we have is we show you the highest grossing movies in 2000. Actually, it's 2017. They do the research. So then they just see the highest grossing movie. So this one we show the top 5, and also the studio produced that. The growth is in that year. What is the growth we get? So that's why you can see the Gone with the Wind actually very high, but the number, the growth is not really the highest one. The reason is they released in 1939. So we need to add the inflation or everything. So that's why here we have the adjusted growth. If including those reasons, then Gone with the Wind actually is the highest grossing movie. So then we have Star Wars and Titanic, The Sound of Music. Now I believe you watched those movies before. So from here, let's see what kind of chart or visualization we can use to demonstrate the data. Okay, so the first one, let's read our text file. So we have a text file, it's top movie 2017.csv file. So again, we read the text file, then we create a table. So we have the top movie table. So you see here, actually we have actually we have 200 movies, but by default we only show the first 10. So let's do some demonstration on that. Since we have 200 movies, we don't want to show every movie of that. Let's choose only the first 10 movie. Okay, so that's we need to create another table. We call top 10 adjust. So in order to get only the first 10 row, which function we should use? Yeah, we can use take, right? So the take, you specify what kind of row you want to take. So if you remember, we have the numpy arrange function. So your arrange function, if you specify 10, they will create the array start from 0 less than the number you specify. So from the top movies, we take the first 10 row. That means the index is 0 to 9. So that's we get our top 10 adjust movie list. Okay, so you can see here you have the title, you have studio. So actually we care about the adjust growth first, most. So then you can see, yeah, they actually already sorted. And the reason is, I think the CSV file, they already according to the adjusted growth, so they sorted already. So that's our top 10 movies. So what kind of data we want to represent? Since this table is for the highest sale movie, so think what we like is we want to see on the first 10 movie, what's different about their sale, right? So that's why we will have the movie title, then the gross sale is important. So what kind of chart we need to use? We learn line chart and scatter. So actually both are not good about that, right? Because title actually is, it's not, this one not really categorical data. But anyway, they are definitely not numeric data. Because the title actually you can have many different titles. So categorical data, we say they need to have category. So studio kind of have limited category. But either way, since the title is not numeric attribute, so the line chart and scatter chart, they both are not good fit. So if you learn before the Excel or something, yeah, this one actually we will learn how to do the bar chart. But before that, I want to show you other thing. If we're using other chart to display what they look like. So the first thing here we have the growth, adjust the growth. You can see, oh, that's a big number. So let's try to adjust that, the a gross sale that's due is we run to the millions. Okay, so the first thing we have the million array. We run to the third digit for the million. So that's why we get the column of the adjust the gross. We divide by 1 million. So then we run to the third digit. So that's add the million gross into our original table. So we're using the top 10 adjust with columns. So we call millions. Then we add the million column. Okay, so that's you get that. Okay, so that's why here you see later we want to display the title against the millions. But before that, I just want to show you why the line chart actually is not very good to represent. The first one, line chart cannot be the x-axis cannot be just the string. So if we really want to see, we only have the numerical data is years and the gross. So we see here, if we just using the years release and millions, how they look like. Yeah, so that's the line chart you see. So actually one thing we only can see, oh, in 1940 something, then we have one movie that's their growth. So then they drop, then they kind of, so honestly, even they meet the requirement for the line chart. So you see the year grows. Then you have the attribute is the numeric attribute for millions, but doesn't have much meaning, right? Also for this example, for the top 10 sale movie. Okay, so that's why here we focus on you want to see the title and the growth. So that's why we introduced you for the categorical data. Actually, we can do one thing is we call that the bar chart. Okay, so we want to see for different title, so then how their million gross sale is. So you will see they look like that. Yeah, so you see in this example, the bar chart is much better, right? So you can see the title, we display different title name. So then the growth is different. Okay, so that's why you can see we have the millions growth. So then they start from the top 1 cell and to the number 10. Yeah, so this one is good for the bar chart for the categorical attribute. So now how about you try to create a bar chart? Okay, so we want you to try to see, can you create this chart? We're still using the bar chart. So we have the title. So then we just want to see all the top 10 movie, how old they are. So the number of years since release. And so how we will create this one. Yeah, post the video. Think about how you will make this one. We already have title. Okay, so what we are missing is the release age, right? Okay, so pause the video, think about that. So then I will show you how should we do that. Yeah, so you can see the first thing we're missing is the years, right? So let's create our years. So let's get the years column first. So we have our top 10. So we get the year. Okay, so using this year, okay, so then we add to our table. Okay, so then here is the age. So this age actually is what? Yeah, it's the current year. So we are 2024. Okay, minus their release year. Okay, so that's why we get the years. Then we see, let's see here first. Let's see our table first. Okay, here I have typo. Okay, so that's we got the year. Okay, so then we will just add the year to our top 10 adjust table. So we see the age. Yeah, so of course you know how to create the other bar chart, right? So then we're just using the table. Okay, so then we create our bar chart. So we're using the title and the age. So that's the title against their age. So of course, see if you can do by yourself. That's the answer for our exercise. So that's our bar chart example. So let's finish our lecture 7. So the visualization fundamentals, we want to remind you. Yeah, here actually is another bar chart. It's a fancy chart, but sometimes we don't recommend you to do that. Because when you do the demonstration, we want you to visualize the data. We want to have more sense to get the data you get. So this one is over the years, how many doctors with other profession and with their salary. So that's why actually it's kind of difficult to compare with this bar chart. You do have the number, but I need to very detailed to see the number. And for example, we have the year. This one is 1970 to 1972. So we want to see the difference in 1972 and 1970, how they jump. Do we have jump high, quicker after the 72 or before? But from the bar chart, we cannot see very clearly. So that's the example if you make your numerical data in the bar chart. If we change to the line chart, don't you see that, yeah, it's simple chart, but honestly, it's much easier to see. Like earlier, we say you see 1970. We see from the two segment here. We can see this one actually they have higher slope. So that's why we know the change will more than the next 2 years after the 1970. So that's why sometimes when you choose your chart, it's important according to your data. And also one thing is, we really don't want you to do too much decoration. So the good practice, less can be more. Remember, you are not create a fancy demonstration is your goal. Your goal is to show your data efficiently and clearly for people to observe what the secret or question behind that we can discover more. So minimize your decoration. And also the color you need to choose carefully. So not make too many different colors. So people kind of difficult to remember which color represent for. And also make your color is easier to see the different attribute. Okay. So if the data are numerical data, preserve their relative value and distance between them is important. Like earlier we say, line chart, slope has their meaning, right, from the algebra. Okay, so that's why you know for your data the same thing. The distance, the difference between two data, when you graph in the line chart, the slope has their own meaning. Okay, so here also we want to show you another example. So that's the tax cut they want to show you. If Bush tax cut expired, before they only have 35%, but after 2013, this one is from news, they will jump to almost 40%. Actually, it looks crazy for this chart, right? But it's really that big difference. Here is 35%, here is 39%. They just choose the kind of segment on that. So they just, that's the entertainment issue. They didn't really deliver the data correctly to you. Yeah, so you can see here, actually, if you really make the real chart, the y-axis start from 0. Here is the 35%. Here is 39.6%. Also, that's important for your y-axis for sometimes. It's better you start from 0. Like earlier, our example for our percentage for the female. So then because they have the 50% ratio is different, but it's better start from 0 for your y-axis.